How are we doing, guys? We're looking at Text and Tests, chapter 16, point 2. So we're looking at a couple of theorems here. The first one is this one. If three parallel lines cut off equal segments on some transversal line, they will cut off equal segments on any other transversal. So what does that mean? Well, it means if you take three lines that are parallel to each other, okay, so I'm going to just draw them in here. And you can use the lines in your copy to help you draw this, or you can draw them correctly, which is probably the better way to do it, just in case you don't get lines in any circumstance. These three lines are parallel, and you might have seen that I had dots on the page. Just make sure that I was putting them the same distance apart. Which means if I draw this line here through my three parallel lines, that's called a transversal. Okay, if I measure that distance, I'm going to find that. What's that? That is about 18 millimeters, and that's 18 as well. Okay, which means that the transversal, these two transversals are the same length. Well, what the theorem says is that any other transversal I might draw will also cut off segments of the same length. So let's have a look. Well, that looks like it's about 23. And this here, 23 as well. Okay, so these two segments are the same length. So that's what our first theorem says. It says if you have parallel lines that cut off equal segments on one section, or one transversal, then any other transversal will also be cut into equal segments. Okay, our next theorem, and a theorem, by the way, is a statement that needs proof. Okay, a statement that doesn't need proof is called an axiom. So an example of an axiom might be that there's 180 degrees in a straight line. But theorems need proof, and we'll be looking at proofs of theorems later on. Our next theorem is that a line drawn parallel to one side of a triangle divides the other two sides in the same ratio. Okay, so again, I've drawn out this triangle, and I've got this dot here is 2 centimeters along this line. Okay, you can see it there, whereas the line itself is a 5 centimeter line. So that means this is a 2:3 ratio. Okay, and the theorem says, well, this will also be cut in a 2:3 ratio. Well, let's have a look. Now, this line here is parallel, so if I put a parallel line through this side, such that the left hand side is in a 2:3 ratio, my theorem says this will be a 2:3 ratio as well. Let's just measure that, see what we get. That's going to be 4, 45, 6, 47. I hope this might come out a little bit shy, just because of the measurement. 47 and 33. Okay, so if that's a 2:3, is this 2 and this is 3? Well, what's 1? 47 divided by 3 is 15.66, and if you multiply that by 2, you get 31.33. Okay, so it's close enough. So we're in within our kind of error, and there's going to be error in your measurements here. We're in a 3:2 ratio there. Okay, it's not perfect. But let me show you just how you could have calculated that if you wanted to. If I said, well, if that's x, this will be 8 minus x. And you would have said, well, x divided by 8 minus x needs to be the same as 2 divided by 3. Okay, so that will often be how we write it down. And if you solve that equation, which I'm not going to do now, you can find that distance x, which should come out as something around 3.3 centimeters. But not quite, because that's only a measurement. Now, the orientation doesn't matter at all here. So if I decide I want to draw my parallel line this way, okay, and if I decide I've got a dot here Okay, well, that's a 2 centimeter out of 13, so that's a 2, and that's an 11. So that's a 2 is to 11 ratio. This has also been split in a 2 is to 11 ratio. Okay, and again, measuring, it won't come out perfect, but let's do the calculation. If I call that x, this is going to be 9.8 minus x, so we can say x divided by the bit left over, which is 9.8 minus x, should be the same as 2 over 11. And I will solve that one. So cross multiplying, I'll just do it down here, we get 11x equals 2 times 9.8 is 19.6 minus 2x. Bring that over, you get 13x equals 19.6. Sorry, now I'm really cramming this in down the bottom. I'll finish it over here. X equals 19.6 divided by 13. Okay, and what do you get there? 19.6 divided by 13 is 1.5, roughly. Okay, do I have a 1.5 centimeter line up here? 1.5, just shy of it. Okay, which is probably more to do with the drawing than anything else. And our last theorem is the converse of that one. Okay, so the converse means reverse the if and the then statement. So we're saying if you draw a parallel line through one segment, you'll cut the other segment in the same ratio. Now we're saying if you cut both segments in the same ratio, then the line that you draw between those two segments will be parallel to the third side, to the base. Okay, if a line cuts two sides of a triangle in the same ratio, then that line is parallel to the third side. So I've drawn this out already. This is a 6 centimeter line here, and I've split that into 1.5 and 4.5, which is a 1/4 of the way along. So that's a 1, that's 1/4, and that's 3/4. So this is a 1 is to 3 ratio. Now, what do we get here? This is 2 is to 6 is a 1 is to 3 ratio as well. So if I connect those 2 points, and I've drawn them already and I've measured them out, and hopefully you trust me that I measured them out. If I draw that line, the theorem says that the two lines now here will be parallel. Well, let's just check that. Let's slide this up now. It should sit in lovely. Okay, so there you go. Two lines are parallel. Okay, so that's the converse of our theorem. One last thing I'll just draw your attention to. This relationship here, that 1.5 over 4.5 will be the same ratio as 2 over 6. Okay, that's working with kind of the bits that you've cut. But you could just as easily say that 1.5 over 6 is the same ratio as 2 over 8. Okay, both of them work out as 1/4. Both of these work out as 1/3. Both of these work out as 1/4. And the last thing you could say is 4.5 over 6 should be the same as 6 over 8. And both of those work out as 3/4. Okay, so there's multiple ways. Depending on a problem, you might want to pick one ratio over another. Okay, so let's look at some problems. We're going to look at question 1, 4, 6, 8, and 11. Question 1 says, find the value of x in each of the following figures, where arrows indicate parallel lines. Okay, well, those are equal transversals, so these must be equal transversals as well. X is 10. These are equal transversals, are equal segments on a transversal, so these must be equal segments as well. X is 12. These are equal segments, therefore these must be equal segments. X is 14. Okay, what did I say? 4. Examine the given diagram and work out the values of x and y. Okay, so again, you've got equal transversals here, which means these must be equal as well. Okay, 15 and 3x must be the same, which means 15 equals 3x, x equals 5. These transversals must be the same as well. 20 must equal y plus 6, so y equals 14. Okay, I'll just write that down. Question 4, 15 must equal 3x, so 15 divided by 3 equals x is 5, and the second part is that 20 must equal y plus 6, so if you move that over, 20 minus 6 equals y is 14. Question 6 says, in each of the following triangles, the arrows indicate that the lines are parallel. Find the length of each of the line segments marked x in each triangle. So this is the thing about ratios, and it's that x over 5 is the same ratio or the same fraction as 3 over 6. Okay, now you write that out. You always put your unknown on the top of the fraction. Doesn't matter where it comes. So for question 6, you're going to say x over 5 is the same as 3 over 6, and then dividing by 5 on the right, on the left, sorry, becomes multiplying by right on the right. 3 multiplied by 5 over 6, and that's 15 over 6, which is 1.5. That's the first one. Okay, maybe pause the video there and see if you can write down the relationships for part 2 and part 3, and I'll do them in a second. Okay, for part 2, hopefully we're saying x over 6 is the same as 6 over 4. Oh, can't see that, sorry. X over 6 is the same as 6 over 4. And for part 3, hopefully, we're saying x over 4 is the same as 5 over 3. So for part 2, x over 6 equals 6 over 4. And for part 3, we're saying x over 4 equals 5 over 3. Okay, to finish that, x equals 6 times 6 over 4. 36 over 4 is 9. And here, x equals 5 times 4 over 3, which is 20 over 3, which is 6 2/3. Now, question 8 asks, find the values of x, y, and z in each of the following triangles where the arrows indicate parallel lines. So this is the thing where you say, well, now I'm working with this side and the big side. So x over 15 is the same as 8 over, how long is that? 8 plus 4, 12. So 8 part 1. We'll say x over 15 is the long side of the triangle, is equal to 8 in the short side over 12. And actually what you're looking at here is similar triangles, and you're saying the corresponding sides of similar triangles are in proportion, but it looks almost the same as the questions we were doing in question 6. You're going to get 8 times 15 over 12. You have a common factor of 3 top and bottom there, don't you? That leaves you with 4 and 5, so you get yourself 10. Part 2 and part 3, again, I might give you a second, see if you can try them yourself, please, and I'll do them in a moment. Okay, part 2, you're going to say y over 18 is the same as 9 over 15. And part 3, you're going to say z over 16 is the same as 10 over 14. Part 2, you're saying y over 18 is the same as 9 over 15. And for part 3, you're saying z over 16 is the same as 10 over 14. Okay, I'm finishing that. Y equals 9 times 18 over 15. Z equals 10 times 16 over 14. What do we get here? Common factor of 3. 9 sixes are 54 over 5 is 10.8. And here you've got a common factor of 2. And you get 80 over 7, which is 11 and 3/7. Okay, and lastly, let's have a quick look at 11. In this triangle, XY is parallel to BC. So if AY over YC, AY over YC is a 7:3 ratio, not necessarily 7 and 3 centimeters, and AB is 15 centimeters, find AX. Okay, so if I call AX, I'll call that unknown. I'll call, what if we not use ABC? I'll use P. Okay, so P over 15 is the same as 7 over 10. Okay, that's what we can say. Even though we don't know the distances, we know the ratios. So P over 15 is the same as 7 over 10. Solve that, you get P equals 7 multiplied by 15 over 10, which is 7 multiplied by 1.5 is 10.5. Okay, we'll leave it there. Talk to you later.